You.
Thank you. Thank you so much for that intro. Great. And thank you for providing this platform to speak on this very important topic. And now that Ivan has raised the benchmark to a very high level, so I have to live up to it. So, guys, I've shared that link with you for that survey that is to serve as foundation for our discussion ahead. So, let me see. Okay. So, a lot of South Africans here, and people think that share responsibility. If not, then it's a female. Gas is okay. Uh, mhm. And then about ethanol. Okay. So with this, let's jump into the crux of it. So I think, to be honest, I don't think I would be sharing something which you guys already don't know. Probably you know all this stuff already. Maybe you have bumped into it into your peripheral visions, but never really thought about it. Uh, Even myself, before joining KOKO, and I'll talk about KOKO later. Before joining KOKO, yes, I knew this stuff, but I didn't care too much because it was not affecting me, and I didn't see that how it is affecting the world. Like you eat chicken burgers, it's all good, it's tasty, but you don't see the slaughter behind those chickens, burgers. So that's how this problem is. Um, I'll be talking more about what the problem is, how severe it is, uh, and then how we are trying to solve it, or we are attempting to solve it. And then I'll be talking about how KOKO is trying to contribute into solving this problem. And since it's a UX conference, how and why and in what capacity is design contributing. And then, yeah, we'll talk more about design. So, okay, quickly jump into what we have here. So, talking about the severity of this problem, let's do a revision of our science classes in our schools, which probably as adults we have forgotten. Talking about energy, so we have two kinds of energy with us. So, one is renewable, another is non renewable. And just one more thing. So, I'll be sharing the link for this board later so you guys can chill, relax, and just focus and enjoy this conversation. So, okay, coming back here. So, energy, two types of energy, renewable, non-renewable. Renewable, as the name suggests, it keeps on getting generated and we keep on exploiting it and it keeps on regenerating itself. Non-renewable, on the other part, like coal, like fossil fuels, natural gases, it will deplete at some point of time. Interestingly, in India, sometime back, a few weeks back actually, it was declared that we have only 2 days worth of energy left. It was propaganda, media propaganda, whatever, but that was the news that we have only 2 days of energy left. Why? Because we had only 2 days of coal left in India, and 80% of energy, at least in India, that's produced by coal. So there were power cuts and there was a lot of hue and cry, but that didn't happen. But that was the news, and it may happen at some point of time. It's not impossible. With coal comes a lot of disadvantages, like it happened in India, but that's at a larger scale. The smallest scale problems would be that it produces a lot of toxic gases. Yes, it can be procured easily. It's cheaper, but its long-term use is the price of long-term use that's high, and it causes a lot of health problems. Uh, Now, I don't know if how many of you thought about this, but deforestation is directly linked to CO2 emission, carbon dioxide emission. I mean, like oversight would be the trees cut. How will it produce CO2? Yes, it will not absorb CO2 as part of its living process, but how it will expel CO2 into the atmosphere. So the reason is that a lot of our trees, they have concealed, they store carbon dioxide into their bodies, their trunk, their leaves, their branches, and when they're cut, and because the matter changes into another form by burning or through other means, CO2 is released as a process in the process of doing such things. Now, if you see the graph here, and a lot of stuff on my board, it's actual data. It's not verbal and what I think, but this is taken from one or the other places, which actually are delving into these form of researches. So if you see the global emissions, a lot of out of the entire global emission, almost 12% of it is through deforestation, and this is just about carbon dioxide, not any other gases. Moving from here, Uh, since 1850, the temperature has really risen, and 1 degree is a lot over all these years. And if you compare these two graphs, with the temperature increase has also increased the CO2 emission. The interesting dip here, if you see this dip, this is actually when COVID happened, and then everything stopped. And since everything stopped, we stopped exploiting nature, and hence the CO2 emission dipped. This one talks about if nothing is done, if no policies are in place, then we'll be experiencing 4 to almost 5 degrees of climate temperature increase. You see here, over all these years, we had a 1 degree increase. In few years, it would be like this. And if there are some policies, it would be, we can still manage, but then still there would be some temperature increase. But yes, the temperature will increase because of the kind of activities which we are doing. What kind of precautionary measures are we trying to take? One is the obvious one, let's stop the emission of CO2. The other one is whatever CO2 is there in the environment, let's absorb it. Some people favor this one, some people favor this one. But the ideal scenario would be that we have a combination of both of these, that we stop the production of emission of CO2, plus we also absorb whatever CO2 is in the environment. I'll be sharing this board so you can have a look at this in detail because we have limited time, so let's move quickly. Another important thing which I wanted to share with you guys is a lot of time we are told that if you're cutting a tree, then we should plant a tree. But the funny part is, after only like 10 to 15, sorry, after 10 years, and in the span of 15 to 40 years of planting that tree, when the tree grows, only then it absorbs a substantial amount of CO2. It doesn't absorb when it is 1 year, 2 year, 3 year, 8, 9, 10 year. It's minimal, but the chunk of absorption happens here. So in 10 years, you would be 10 years old, your kids would have grown up, the life would have changed, the earth would have rotated 10 times. uh, it's not worth it. So we have to do something now instead of waiting for that tree, the forest to grow and then absorb CO2 and then help us get on a better life. So with this, for this first section, which was about the problem, the takeaway is that we should try and reduce the usage of fossil fuels because it directly impacts the flora and fauna on our planet. Now, with this point, what happens is the other part of conversation is how does the world cook? And I saw from the survey, a lot of folks think, a lot of folks themselves, they think that gas is the popular medium or electricity. In fact, when I traveled, by the way, I'm in India right now. When I traveled to South Africa, I've worked for quite some time in South Africa. That was the first time when I cooked on electricity. In India, we use LPG most of the time. All my childhood was we were cooking on LPG. I knew that we can cook on electricity, but I had no reason, never had to cook on electricity. Uh, yeah, a lot of people think that it's fire, gas, it's gas. Okay, so gas is the popular one. Interestingly, that's not the case. So 60% of the world doesn't have access to clean fuel. So by clean fuel, that's gas, that's electricity, that's LPG, some natural gases. That's not the case. That's for the privileged ones. So if you see here, a lot of countries here are at the bottom segment of this graph. If you look at the top part, these are the developed ones who use clean fuel, but majority of them, they don't. They don't have access. They don't even know it exists. In India, even for LPG, we have a subsidy mechanism. That's why some of the lesser privileged people can still afford LPG, but a lot of nations don't have that privilege. So even India is it's an edge case, I would say. Now with this graph, if you compare, actually this is a variation of this graph. So if you see the axis, okay, I'll move it here. Okay. So the access, the population which has access to clean fuel, the top ones, the darker the color, the more access they have. And the lighter the color, they don't have that access. So even South Africa, it's one of those privileged ones. Australia, America, India lies in between. Most part of Africa, nope. What it means is there's something called energy ladder, which means that the more you earn, the richer you are, the more access to clean fuel you have. So clean fuel is this, the top part. You are more prosperous, the country is more developed, hence you have access to those cleaner fuels. The lesser money you have, the lesser privileged you are, then you use those rudimentary elements for cooking. You use crop waste, dung, wood, charcoal. What it also means, okay, let me go here. So from this graph, if you see the privileged ones, the deaths related to indoor pollution. So you're more privileged, you have clean access to fuel, lesser deaths. Lighter the color, lesser the deaths. Darker the color, more the deaths. So if you have less access to clean fuels, if you're cooking on charcoal, wood, crop waste, dung, then there are more in-house deaths happening, indoor population. And interestingly, indoor population is not less deadly than outdoor population. And I'll come to that. This talks about the same stuff which I spoke. So you have access to cleaner fuel and the lesser deaths you have. So this is you have 100% access to clean fuel, less deaths, less access to clean fuels, and more deaths happening. Now this leads to this observation. If you see here, the developed countries, and if you read the legend here, green stands for LPG and electricity, so they are cooking on LPG and electricity more and some other fuels. And if you compare this to sub-Saharan Africa, there's very less of green, probably the privileged ones. And there's more of blue, and blue is basically solid fuels, the charcoal, the wood, dung, coal. This and because of usage of this charcoal, because they don't know what else can be used, they're not aware, or even if they're aware, the economy doesn't allow, the logistics don't allow, and this leads to a lot of deforestation, and probably 2 million hectares per year, which is multiple times the size of Manhattan, just for comparison. And what it does is when these fuels are burned, they release a lot of carbon dioxide, a lot of other gases, NO2, which, when inhaled, causes a lot of problems. Now, this takeaway from this one would be I'm breaking it into small chunks so it is easy to absorb. Uh, Low-income households resort to dirty fuels, and indoor pollution, it's a serious issue. Now, let's dive into what does indoor pollution look like. And I've concentrated and focus on the Kenyan geography because that's what I'm focusing on right now. In Nairobi, almost 60% of the population, they live into informal settlements, slums, smaller houses, less than 50K income, shilling. Uh, and because the houses are such and they cook indoors, it kind of fills up their home, and then it causes a lot of health issues because of those harmful gases being released from those mediums. Now, 3.8 is the annual mortality rate, and out of those 3.8, 7.7% is just from Kenya because of indoor pollution, which amounts to almost 300 deaths per week. That's too much. It seems even more if you compare it with the fatalities from road accidents. So 3.5K fatalities from accidents and 21.5 deaths just by cooking, doing nothing else. They just die indoors in their houses because of health problems, because they are cooking, because they want to live, hence they have to eat. And in the process, they have health issues and sad death. And of these deaths, almost 50% are children, which is really, really sad. Uh, this is how a typical home looks like. Uh, I'm not sure if people on the call have actually seen something like this. If they have, it's good. At least you have a reference point. And if you ask me, you should be doing something in this respect. I feel ashamed about myself because I was not up to this point. I was not contributing in any way for the upliftment of such unfortunate, unprivileged folks. So yeah, this is how it looks. Things may seem rosy in our AC rooms, good cars, but then life is not rosy for everyone. Uh, yeah, so like I was saying, it releases a lot of harmful gases like SO2, nitrous oxide, CO, a lot of others which I have not mentioned here. But then the point is, it's not safe to cook indoors, and still unsafer when your windows are closed, it's raining outside, or it's cold outside. The rosy part is, and also the not rosy part is, the use of solid fuels, it has decreased for a lot of countries over years. Yeah, so this graph is from 1980 to 2010. I'm sorry, I was not able to fetch something about 2020, but at least 2010, it gives us an idea that it has decreased. But unfortunately for Africa, it has not decreased as much. Another data point, like I was talking about the good part. So the good part is that the deaths because of indoor pollution, they are decreasing across the world. So this is a comparison. So the gray part is that's due to outdoor pollution, and the blue is about indoor pollution. It's decreasing. It's a good thing. But then if you zoom into sub-Saharan Africa, oops, things are not good. So they are the deaths itself, they are not decreasing. It's either plateaued or even in comparison, it's more than deaths due to outdoor pollution. And then if you compare it to one of those developed parts of the world, then it becomes even scarier because this blue line, 1 point line which you see here, this one, this is deaths because of household pollution, aka indoor pollution, very minimal. And speeding cars deaths, probably they are more, but then at least the indoor deaths, they are less, almost negligible, but that's not the case in Africa. So uh, like in UX, we have that framing principle. So now this becomes scary. Okay, so from here, let's zoom into what we are doing at KOKO. So KOKO Networks, it's climate technology enabled business. So we use technology, like we are using technology for various means, like Ivan was talking about fast forward technology and what we can achieve in near future. Uh, we are trying to use technology, and basically in layman terms, it would be a IoT system, how we can help these unprivileged folks. So, and I'll talk more about that. So we are using ethanol as a fuel. From the survey, I think a lot of folks you know about ethanol, a bit at least. That's good. Uh, no, so I'll help you out now. So ethanol is basically a byproduct of sugar. So once you're producing sugar or you're processing sugar in various forms, this is something which gets thrown out in the sewage. But luckily, it can be used for emission, for burning, and it produces no vapors. It produces it's a liquid. So like LPG, it doesn't have to be compressed. So since it doesn't need to be compressed, there's zero chances of explosion. And even if there's a leakage, it will just spill over, it will burn, it will evaporate, and then done. So no fire casualties. Even in Coco, in my tenure, and even before that, we have not had any incidents where there was a severe casualty because of a fire casualty because of ethanol. Okay, so we use ethanol as a fuel medium, uh, and I'll show a video of how we do it. So how this ATM thing, like I'll show you again. I keep saying I'll show you. I'll show you in some time. So this is like a ATM like machine where you can go in. You can have your canisters docked into this ATM like machine, and it dispenses fuel. Fuel is ethanol, and this is the cooker. We call it cooker. Basically, for this session, we can call it stove. This is something which we designed. Actually, all three of the stuff we designed in house. This uses ethanol as a fuel, and you can burn it safely. And this bottle, which you see, this bottle docks here. Actually, here fuel goes in, and when the bottle gets, and you can detach the bottle, you don't have to keep it placed for burning. And then you can use this bottle as refilling for you can go to this ATM, you can dock this bottle in this part, and you can enter your amount, your fuel which you want to dispense, and then the bottle gets filled, you get to home, and then you are set for a week for a typical household. In the course of doing this, okay, let me first show you. uh, I think I have to remove my headphone for you to listen.
Supreet, your mic is muted. Sorry. No, it's still muted.
Oh, it's now. I was not
Yeah.
able to unmute it.
Can
Uh, you guys able to hear me now?
Yep, can hear you perfectly.
Okay, great. I was not able to unmute it for a while. Okay, cool. So I was saying that there are organizations set up in the world, which kind of like UN, they kind of take care of for the betterment, that everything is not polarized just towards technological development or economical development, but also for safeguarding nature. So out of those 17 principles, and I have the link there. So once I share the board, you can go to the respective links. I place it all over the board so you can explore on your own. Uh, so out of those 17 links, captured four which Coco is adhering to. So no poverty. So the process of setting up these Coco shops is just not about charity, but we are also empowering the population there and establishing a business. So you have the 700 numbers which I mentioned here. So these basically are 700 shops which have those ATM kind of things. We call them Coco points. These shops basically give business to those respective shop owners. They have another source of income, and then they also act as uh, places where the neighborhoods can get together and talk about stuff, and in the process make purchases. To make all this happen, um, we have a whole lot of team members in Nairobi and in India. So we have a big logistics team. We have a lot of people like myself working in the design team. We have a big product team. We have a lot of drivers in Nairobi for dispensing for logistics of fuel and logistics of these cookers, stoves, and all these the bottles which you see. So there is a lot of empowerment and employment which we have created in the Kenyan geography. Good health and well-being, as it's very evident now that it's a clean fuel. There's no harmful vapors. There's less of dirt in their home. So in totality, it leads to better health. Climate action, because less emissions, less deforestations, and less of everything which is contributing to and caused by that dirty fuel. Life on land, basically less deforestation, and it has a ripple effect on a lot of things. Okay, so and yes, we won few awards recently. uh, like I mentioned, it's not a it's a great business model which we are operating into. So we have won awards into these, as you can see. There's another video which I would like to show. Hopefully, my mic doesn't stop working.
Cooking solution. Maisha ni okay, okay. Maisha ni Coco.
So this was our TV advert. Uh, I'm fearing the earlier video which I shared, it didn't had audio. Did it? The-
I don't think it had, but it had subtitles.
that saved me. I, I only realize it now. You have to change every time I switch off. I plug out my microphone. I have to change my settings. So
Yeah, so we can hear you perfectly.
okay, yeah. Yeah, this is just a snapshot of how tankers look. So the one you see here, this is basically one of our tankers which runs uh, in intercity, intracity. So we have depots, big depots. I'll quickly jump here. Oh, yeah, this is how it works. So we have areas in big petrol pumps, gas stations. We are partnering up with Vivo in Kenya. In these big stations, we have small places where this ethanol gets dropped in. The small tankers, which I showed you earlier, those tankers pick up ethanol from those places and then they move to respective shops. Shops I'll okay, shops look like this. So these tankers, these pick up ethanol from those petrol stations, and they go into shops. And shops look like on the map they are spread all over Nairobi currently. And if I move here, yeah. And then from these shops, people can come in, they can refill their canisters. You can see there's ATM like stuff. That's our Coco Point. They can refill their canisters from the Coco Point using their M-Pesa accounts. That was interesting for me. That all this is happening digitally, so there is very less of cash involved, and then they can cook happily in their homes. And yep, yeah, let's go there. So yeah, now zeroing down, focusing on this part, that how is this magic happening, which I kind of explained now. Uh, you have already seen in the videos how this cooker and how these canisters work. If you see, there's a lot of design consideration which went into it, and this was obviously not the first one. We went through the entire design process. We had a lot of iterations in the market of what works. One of the main USP of such a cooker stove is that it has two burners. So mostly people use one burner stoves. Uh, Something which they like in our cookers is that it has two stoves and they can quickly, in less time, in the same time, parallelly, two dishes. The bottle itself, just an example, it has a see-through body, so you can see how much fuel is left in the bottle. And this bottle capacity is 2.3 liters. And putting in perspective about this ethanol, how cheap or expensive it is, uh, it's cheaper than gas. It's a bit expensive than kerosene, but then off lately, uh, the prices of kerosene have risen. The prices of gas itself, they have increased. That puts us in the sweet spot that the competition has reduced and it's more affordable. And the good part, I mean, these are small details which matter. The good part is people can buy this fuel in any denomination. So they can buy 2.3 liters, they can buy 1 liter, they can buy lesser than that, whatever kind of money they have for that day. For gas, you have to purchase that big cylinder for 6 kg, let's say. Yes, the run rate is less as in it's cheaper in the longer term, but then you have to pay upfront a big amount, and it's bulky. So yeah, and this is our men in action. So this truck which you see, we call it micro tankers. And again, there's a whole lot of IoT happening here. a whole lot of mechanisms, whole lot of tracking, measuring, a whole lot of legal things happening in this small truck. And they use this pipe to dispense fuel or dispense ethanol into those respective KPs. And then uh, also there's a mechanism for filling this micro tanker itself. So not a easy task, I would say. And this ATM itself, that's interesting because here, as you must have noticed, you dock the bottle. It has a screen here, which again, it opens up a whole lot of opportunities for anything which can go on a screen. And then it has an ad space here. So it serves as a medium for doing multiple things. It can dispense fuel as a default thing. It can serve as a digital machines. We were also running some digital ads some time back. It can also work as an e-commerce kiosk. Basically, anything which you can think of, which can run on a screen, 2D screen. Again, just putting in perspective of how big and not so easy task it is, this is how it gets manufactured in our factory in India. And we have a huge factory. This is how it looks. And this is how our friends in Nairobi, the stuff which they do. So the parts come from India, and parts about the ATM thing, parts about the cooker, parts about a lot of things. They come and then they get assembled into Nairobi, and a whole lot of stuff happens in Nairobi. So bottom line, it's not an easy task. Now, let's come to this interesting section, that what role does design has to play here? As you might have guessed, we have a lot of interfaces. So we have interfaces for tracking what's happening in the field. We have interfaces for how fuel trucks or where the fuel trucks are, when it has to be scheduled, where it has to go, where is the driver, is he on leave, who has to be allocated, which truck is in the vicinity, is the truck even working or not, whole lot of stuff. And we have interfaces for that. We have systems on those pump stations as well, uh, and somebody has to, and it's basically fuel. Something can go wrong, and you have to be very careful about that. So specific systems are in place. We have interfaces who help us track, dispense, stop, raise errors, raise issues, notify about everything which is involved with dispensing this fuel. And then we also have apps which our customers use interacting with us, our sales guys use, our shop owners use for doing multiple things. Even we have apps which our drivers use and which a lot of people in the ecosystem use for their respective activities. So again, the bottom line is we have a lot of interfaces. Now, with those interfaces comes another set of challenge, that we have a very unique customer base. These customers do not have all the wealth in the world. They have a very specific household conditions, very specific income group. They have very less exposure to technology. So compared to the exposure which a lot of us have, I'll talk about myself. I've worked in e-commerce. I've worked in banks in South Africa. I was working with NetBank. I've worked in media industry. The target users for all these companies for whom I've worked is very niche, I would say, or at least they are technology enabled. But these folks, they don't use smartphones that much. They rely on SMSs, they rely on USSDs. Yes, they have smartphones, but then data is too costly. So if you think of a cool feature which will look very savvy on a iPhone 13, it will not work for them because they just don't have that sort of luxury. So it poses to us a very different set of problems. And then the value chain itself, it's very complex. So our cookers, they get manufactured in India, and then we have to get raw material from a lot of other places. it gets manufactured and it gets uh, it moves to uh, the Kenyan geography, and then it has to be managed there as well. And then about the fuel as well. Fuel, earlier we were sourcing it uh, in Africa, but then because there is so much of demand, we need to get fuel from other places as well. So again, it has its own set of challenges, and all this uses interface in one or the other form. So talking about interfaces, again, it is about internal users and it is about also customer facing. Our shop owners use interfaces, our customers use interfaces, our drivers, a lot of customer service agents, and a lot of folks, they use such interfaces, which again leads us to that there needs to be some consistency, there needs to be some understanding of who is using our systems for us to be able to design perfectly. So if you see, and this is a observation that most of the refilling, and this was interesting to me when I joined KOKO, most of the refilling happens on these stations by kids. So yes, we have the meal member in the house, but the meal member after making the purchase don't really visit the shops too often. It's mostly the kids or the ladies in the house who make visits for refilling. So this is how it looks like in a typical scenario. Uh, okay, yeah. So point is, for these set of target customers, users, we are using technology, but we cannot expose them to a lot to that technology because otherwise it will bounce. They will not relate to that sort of technology. So technology is important. Technology is used in our sort of business, but we try to keep it minimal. We try to abstract it for our customers, and that is itself challenging. Now, talking about how my design team works in KOKO and especially in the new normal, now that I'm just trying to survive, we work out of two locations, from Kenya and from India. In India, we have office in Pune, if you know. Uh, I'm in Bangalore, by the way, right now, and we use Figma and Miro. And you might have guessed I love Miro, so we use Figma and Miro in KOKO, and I'll just spend some time on how we use Figma in KOKO and how we have customized it to our needs. Probably some of you already are using in this fashion. For those who are not, you can leverage this information. So what we saw initially was that the teams were segregated, and because of the nature of the business, uh, there was not a single source of truth, and especially about design. And I'm sure many of you must have experienced it, that the design comes, uh, people do understand design, but then what should be done in design, that's mostly a afterthought. So yeah, so we introduced Figma some time back, and how we are using it is we have we are trying to use it as a source of truth. So all everything which we are designing, it is laid out as pages, so it serves as a version for all the designs. So instead of having it on GitHub in some way, having it on let's say Jira or Confluence, if you're designing in Figma, why not have your versions in Figma and expose it to your developers, and they can see, they can have it as a source of truth, and then some valuable conversations can happen. So yeah, all the versions on Figma. Then we also thought of adding some documentation on Figma. Documentation probably would look like that. We work in Agile, by the way. So what this story is about, what we are trying to achieve, who are your stakeholders, key metrics, all those things, so that our designers are anchored to what they're designing. And even after 6 7 months, if somebody comes back and looks at these boards, looks at these documentation, they can relate that why something was done, what is the logic, why the iterations, or why something was not done. We also bank hugely upon usability testing insights, and we have set documentation for that as well. We are exploring, but right now this is what we are trying to do. keep everything documented, because I think it's true to a lot of designers that they tend to just go with the flow. Things make sense in that moment of time, but after a few months, the designer also forgets about what was done, and the stakeholder also has no clue, no documentation about why such a design was done, or why, or what was the outcome of certain usability testing. And for those who have done usability testing, they will know that it's a lot of logistics, it's a lot of documentation. The actual part of doing the usability testing, that's actually less compared to all the other things which you have to do. And yeah, so this is something, the kind of prototypes which we do. We try to make it as closer to life as possible. We also hugely bank on creating wireframes before going to mockups. In a typical design process, we use Miro for creating personas, uh, for our journey mapping, so that everybody in the business is aligned of what needs to be done. We do some rapid prototyping with papers, so that all the stakeholders are on board, and we spend less time uh, into iterations, into painful iterations, I would say. And then in the end, I would say it's about teamwork in any organization. No matter how many processes you have, no matter how many cool designers you have, but if they're working in silo, it doesn't click. So you have to work in tandem, and that's what we are trying to do at KOKO. Uh, in the end, I would give you a snapshot of why user research is important, even in KOKO's case. So this is something which we designed, and basically it allows you to. Oh, by the way, our canister, they have a lot of chips and codes, so you can. It's NFC enabled, so there's something called Mobico devices. You can bring it closer to your canisters, and it will simply scan your canister. You don't have to feed it into your devices, into your databases. It simply recognizes it. So this is something which this was the first iteration, and the idea was to scan a full a empty canister, and then to scan a full canister. I'll not go into the exact business details, but this is what it was supposed to do. So scan an empty canister, and then step two, scan a full canister. And we were all happy, jolly, okay, that this works. When we tested with our users, they were scanning all over the place. They were not scanning here where the chip was. They were scanning on the top, on the bottom, everywhere. And we were curious that why they were doing so. And then we learned when they said that you only told, right, full canister, you have to scan the full canister. So I'm scanning the full canister. Then we realized, oh, okay, we didn't meant to scan the full canister, but we meant that when the canister is full with fuel, then you scan it. So the system knows that, okay, this canister is now filled with fuel, and this is ready to go. So things like that, they click. Uh, we learned, and we still acknowledge. I mean, as a designer, of course, I know, but this was treated as an example at KOKO for everybody else to acknowledge that research is important, because because KOKO is growing rapidly, because uh, I mean, people come from different walks of life. They have different experiences, different professional experiences. So, as a designer, I would say, I think for all my life, I would be spending trying to vouch for design, trying to fight for design, that why it is important, and what benefit it gives to the business in the longer run. So yeah, so with this, and with this big crowded board, hopefully not boring board, I wrap up my talk. Hopefully this was insightful. I was able to share a few pieces of wisdom with you guys. Thank you.
Supreet, thank you so much for the talk. And